8.3a is on real-life applications using our polynomials in factored form. So if you think back, this arch shape or this parabola shape, it's actually found in a lot of different places in real life. Anytime you see like an arch or a U shape, that's a parabola. So we're going to use that fact to answer some different questions. For example, an arch garden trellis is modeled by the following function. Y equals negative 1.8 times x minus 2 times x plus 2. And we're going to use that in order to answer some questions. So the variables x and y are measured in feet, and the center of the trellis is where x equals 0. That means when we're looking at our trellis here, since it says the center of the trellis is where x equals 0, here's a center of my trellis. Okay, here's a center of my trellis. So this would be where x is 0, which means it's on the y-axis. So that means our vertex, right? Because remember, the middle of our parabolas, the center of our parabolas is our vertex, would have the x value of 0. Let the y-axis represent the maximum height of the trellis. Okay, so again, that's kind of the picture we're setting up here, that our vertex is up here where x is equal to 0. And this would be our maximum height because it's the highest point. Then, looking at the information we were given, from the equation we can also find our x-intercepts, right? If we want to find our x-intercepts, well, we want to figure out what happens when y equals 0. Here, let me rewrite this. So when y is 0, we'd have 0 equals negative 1.8 times x minus 2 times x plus 2, which means in order to make that true, either x minus 2 is equal to 0 or x plus 2 equals 0. So our x-intercepts are 2 and negative 2. So I'm going to put that. Here would be my negative 2. Here would be my x-intercept of positive 2. So looking at this and looking at this model and this kind of picture that we drew with our x and y axis here, we can answer these A and B questions. So estimate the distance across the trellis. So if we're looking, our distance across the trellis, right, it would be this distance right here, which happens to be the distance from one x-intercept to the other x-intercept. Well, if we look, how many points, or how far is it from negative 2 to 2? Well, it's 2 to get to 0, and then it's another 2 to get to 2. So it's a grand total of 4. For what? Well, we said we were measuring in feet, so it is 4 feet, which means that the distance across the trellis is 4 feet. All we had to do was figure out how far apart our x-intercepts were. Now, to estimate the height of the trellis, we know that the height of the trellis is where x is 0, and so if we know it's where x is 0, we can just plug that in to find y, and that's all we need to find the height. 0 plus 2, well, we'd have negative 1.8, 0 minus 2 is negative 2, 0 plus 2 is 2. When we multiply negative 1.8 times negative 2 times positive 2, that is 7.2, which means that the height of our trellis is 7.2 feet high. And those are our answers. Let's practice one more. An arch is modeled by the following function. Y equals negative 0.15 times x minus 8 times x plus 8. The variables x and y are still measured in feet. The center of our arch, so here's the center of our arch. It's still where x is 0. So again, that means that our vertex is the point 0 something. We want to let y represent the maximum height of this arch. So if we want to estimate the distance across the arch, well, we want to figure out how far is it from this x-intercept to this x-intercept. Well, again, from negative 8 to 0, that would be 8 feet. From 0 to 8, that would be another 8 feet, which gives us a grand total of 8 plus 8 would be 16 feet. It is 16 feet from the one end of the arch to the other end of the arch. Estimating the height of the arch, well, here's the height of the arch. We know that x is 0, so in order to find y, we are just going to plug that in. Negative 0.15 times 0 minus 8 times 0 plus 8, well, that would be negative 0.15 times negative 8 times positive 8. And if we multiplied all of that together, we would get 9.6. In other words, the height of this arch is 9.6 feet. So again, these arches, these parabola shapes, they are very prevalent in your everyday life if you look around for them. And in order to find these measurements, all you need to do is find the absolute distance from one x-intercept to the other. And to find the height, you just need to use the y value. In order to find the y value of the vertex, you just need to use that x value of the vertex.